queue is, as we define, is a first in, first out. Same thing, you will use an array, and in that array there will the values what you insert first, that will come out first. So consider this is in real life example is, say this one, we have a gas pump, a gas station or petrol station, whatever you call. In that, the cars are lined up, and whichever came first, this one will fill the gas and or petrol will go out, and then next one goes in the line. So this is how it is a line or a queue, that's what we call, and whichever comes first goes first. So that is the thought behind a queue in the data structure. This is also used array in order to manipulate data or insert or take out or remove. So the operations are called enqueue and dequeue. Enqueue means add here in the rear, and dequeue is remove from the front. This is front and this is rear. And you can pick the data. So in this example, okay, here is one important concept. We say the data structure, it can use array as well as linked list, but the behavior has to be first in, first out. That's the purpose of a queue. Both stack and queue can use array or linked list. Just the behavior of data insertion and deletion behaves, conceptually it will behave this way. Stack is last in, first out, and queue is first in, first out. So in this example, same like stack, we have 100 size data. You see the definition is the data size is same, but here there are two integers, front and rear, because we need to keep that thing that where is the front and where is the rear in order to insert and remove. So this is the queue, front and rear initialized in the constructor. Check is empty. If front is -1, that means it is empty. If rear is max -1, then it is full. It has to be less than that. And the operations are enqueue and dequeue. In enqueue, element is inserted, and you check whether it is full or not, and then you check if it is empty, and if not, then you increase the rear, that is on the where the data will be inserted, and then you add that element. The first initialization is done with -1, so it will be 0th location where the element will be, and then you keep adding value in the rear side in the array as every element inserted. call the method Enqueue, and that value will be added in the array. And in case of Dequeue, that means removing the data. So what we see, if is it empty? If it is, then display a message and check if front and rear is same. If front and rear is same, then that means we don't have any more data to remove. So you reset it to -1 here. And if not, then you increase the front. That means the front is increased, meaning the first element is removed from the array. Removed in the sense that the index is changed, but actual data is not removed. But now as you read, next time you will have front in the correct location. And when you pick any element, this is how you do. If is it empty? If not, then read the front data. And in our example above, in this case, this is the front, you read. And if you consider is, in this case, we have an array which has, so first front and rear will be -1. And then when you insert 10, you're inserting here 10, and then 20, and then 30, and so on. This is front, and this is rear. So now if you pick the data which is inserted first, that is 10, will be read. And when you dequeue, the front will change here. So the dequeue function, we have this front is increasing. So front is increased to next one, next index. So that will be front in this, after this. And now you pick the value, you print, in this case 20. So in this case it is 10, in this case it is 20. First in, first out.